Welcome back. Today is the second episode of our system design series about talking about rate limiter design, and rate limiter, and basically today is we're starting the second part, and I guess the second part will have like 4-5 videos basically. I guess yeah, it will, because it's the second part. We will talk about a lot about in this part specifically. So if you didn't watch the previous video, I suggest that you could watch it. Anyway, if you watched the previous video but you don't remember basically what we talked about, I'll just make a small wrap up about the previous video. Basically, we had a question that would design a rate limiter, and basically in the system design interview, most of the actual application, most of the actual questions are pretty vague. It's just design rate limiter, design Facebook, design rate group, and our duty as an interviewee is to ask for clarifications and understand the problems and understand the requirements. So this is our thing that we should do first. So basically, in the last video, we try to understand the problem, and we ask for the clarifications and understand the requirements. So basically, we first ask what specific type needs in this needs to be limited, what we are limiting basically. So basically we are limiting the API requests. It's a API focused server, so we know what this service do, and there's 4 or 5 questions that you find yourself that you ask all the time in each system design interview: what I am doing, how big it will be, and it will be distributed or not, what are unique functionalities. There's like 5 or 4 interview questions that you ask all the time, and you will try, when we try to do more and more of that, you will try to understand this better. So basically the second one, it will be, is the rate limiter work based on IP address or user? So I want to know how basically which algorithms that we use, because this will be good when we work with algorithms. So basically the rate limiter will be flexible. So this will make it quite harder, but however, we will continue. What is the scale of the system? Basically, it's distributed or not. So it's distributed. So the scale, we should put scale into our calculation. Should the rate limiter respond the user that being blocked? Yes. So we expect some sort of response. Are there any performance or latency requirements? Yeah, there are. Basically, the rate limiter should not make the HTTP request slow at all. So from this one, we take the functional requirements and the non-functional requirements. The rate limiter must be able to limit the rate of the request for specific type of requests. The rate limiter must respond to the user when the limit is exceeded. The rate limiter must be able to track the rate in real time, because we have low latency. Non-functional requirements, we should have high availability. The rate limiter should have a low latency, high fault tolerance. Basically, when the rate limiter has a problem, the system will continue basically work. Use as little memory as possible, and also has a distributed system. So and so basically that's it. So basically, for today, we started for the second one, was for the second part. Basically, each system design interview, we have 4 parts. We understand the problem, we propose the high level design, we go deep dive into specific area in this design, and after that we wrap up. Maybe we add some improvements, things like that. So in this one, we have the high level design, and we have part 1 of the proposed high level design. It will be, I guess, 6 parts. For part 1, we ask the question where to put the rate limiter. So basically, when we talk about where to put the rate limiter, there is 2 ways to put the rate limiter. Basically, we have to put it in the client side or the server side. The client side implementation, generally speaking, like it's unreliable place, basically, because we don't have full control of the client basically, and maybe it can be affected quite easily by tons of different aspects because we don't have a control on it. So I guess the server side, and I will make a quick pause. Each time when we are designing right now, I said that the client-side implementation general, and I talk about the client-side implementation, and actually I talk why I will not use it if each time I should put my opinion, because and I will say because of that I suggest that to use a server-side implementation, because we had a we had like a full control on it. So each time we said something, we say why and why we choose it. Okay. And every time we ask for clarifications from the actual interviewers to make sure that we are putting the interviewer with us in the discussion. So let's just add this. So basically, let's assume that we have the client, and we will implement it in the server side. So basically, in the HTTP, we have another. This is the server API servers. Okay, and let's just make them quite wider. And I guess I'll just add another shape. I'll add this shape here, but it will be way more smaller. And this will be the rate limiter. And it will be rate limiter. And let's just, yeah. And can we make it like just a little bit wider? Yeah. Okay. And basically, we can implement it like that in the server side, and there is we can just put it with the actual server. So basically, it will work on the actual server. And there is different solution that could work better, which is to make this one work as a middleware. Basically, it will be, let's just delete this one. It will be work as a middleware between the client and the server. Okay, so basically, like basically, in this one that we assume that our let's just give an example, but I guess it will be quite better if we get with the example basically. So I just wanna, can I have the color? How do you change the color basically? Yeah, and okay, and yeah, let's just change the color of this one also, and have another one. No. And let's just make it quite. Okay, and another one, and another one, but this one will be red. I want this one to be red, and again another one, but this one it will not add. So we will send back. We will send this one back, but I need to be like a dot or something like that. Okay, so basically, let's just basically assume that our API allows basically 2 requests, nothing more than that. And actually, the client sends 3 requests, as you see here. Basically, the first 2 requests actually routed to the actual API service, no problem with that. Yeah, the first 2 requests actually it's routed to the servers. However, basically the rate limiter middleware basically it just throttle the 3rd request and returns back to the client with the HTTP. I guess we can have a code of can we add text? It will be like 4 4 to 9, because yeah, too many requests. 4 to 9. Can we make this one can make this one. Okay, we can't. It will be 4 to 9. 4 4 to 9. Yeah, too many requests. So basically the rate limiter basically will catch this third request, because we only allow 2, and it will send it back to the HTTP says goes 4 to 9. That means, actually, I guess if you work with API before, maybe you just make some too many requests, you find that you're getting an error with the 4 to 9. It said like too many requests. What we are doing here is something called a microservices architecture, and actually this has become widely popular, and rate limiting is usually implemented within a component that called basically API gateway. Basically, I don't know if you are familiar with the API gateway, but the API gateway was actually, it's a fully managed service that supports rate limiting, and there may be like SSL termination, authentication, maybe permissions. Yeah, it supports all of that. Basically, also serve static content, etc. Basically, for now we only need to know that API gateway is a middleware that supports rate limiting. This is the only thing that we need to know. Basically, but there is something important while designing the rate limiter here. We should ask ourselves some questions. Basically, where should the rate limiter be implemented, or on server side, or on the server side, in the server side basically, or in the API gateway. So in here, this is the API we implemented as a microservices architecture, and we implemented the API gateway, or should we put it here in the server side? And I would say that it depends. It depends on basically the current technology that we are using, the programming language, the GET service, make sure that the technologies that we're using, if the technologies that we're using are quite efficient, they can work on the server side, and also we can also we know that if we actually already have an API gateway already with our system, and basically if we have already API on our system, we just store it, put the rate limiter space directly in the rate limiter. And maybe also the third thing that we should think is identify basically the rate limiting algorithm that fits our business needs. And I guess this will be in the next video that we will talk about. We'll start to talk about the algorithms, because we have 5 different algorithms that we talk about each one of them. However, in the system design, you will not have to describe each algorithm, but at least you should know the pros and cons of each one of them. However, I will just describe them in depth, so we will try to understand everything basically. So basically, that's it. And right now we went to the conclusion that we could put the rate limiter on the API gateway onto the server side. Depends on the actual architecture that we are using, depends on the actual technologies that we actually have. If we have already API gateway, we put it in the API gateway. If our technologies will not support in our architecture, this will not be proficient for our architecture, we store it directly in the API service. And it's important, again, each time we talk about something in the system design, we should say why we want to do it like that, and what is the pros and cons of each one of them. And yeah, that's it for today's video, and see you in future videos. And basically, before I leave, if you like this video, just make sure to subscribe and give me a thumbs up and hit the notification bell, because actually I found that 95% if you guys are not subscribers, so like if you feel free to subscribe, because this has helped the channel physically and helped me create more content, because it's making me feel happy. Yeah, so yeah, that's it for today's video.